In this video, we're going to talk about how to determine if we should reject or fail to reject the null hypothesis using the p-value method. So let's work on this problem as an example. The average weight of all residents in town XYZ is 168 pounds. A nutritionist believes the true mean to be different. She measured the weight of 36 individuals and found the mean to be 169.5 pounds with a standard deviation of 3.9. Part A, state the null and alternative hypotheses. Now, if you want to take a minute and try this problem, feel free to pause the video and do so. So let's go ahead and begin. Let's start with the null hypothesis. So this is the status quo, and that is that the average weight of all the residents in this town is 168 pounds. So mu is 168. Now the nutritionist believes this answer to be different. So the alternative hypothesis is that the mean is not 168. Now let's move on to part B. At a 95% confidence level, is there enough evidence to discard the null hypothesis? Now we're going to use both methods, the traditional method and the p-value method, so you could distinguish the two. So let's begin by writing down what we know. So we know that the sample size n is 36. She measured the weight of 36 individuals. The sample mean, x bar, is 169.5 pounds. The sample standard deviation, represented by the symbol s, is 3.9. We don't know the population standard deviation in this problem. Now the next thing we need to determine is the significance level. We have the confidence level. The confidence level is 95% or 0.95. The significance level is represented by the symbol alpha and is equal to 1 minus the confidence level. So 1 minus 0.95 is 0.05. Now, in order to use the p-value method, what we need to do is calculate the p-value, which represents the area that corresponds to the z or the t test statistic. If that p-value is less than alpha, we are going to reject the null hypothesis. If the p-value is equal to or greater than alpha, then we must not reject the null hypothesis. So we should accept it. The correct term is to fail to reject the null hypothesis. So we need to get the p-value and compare it to alpha. That's the p-value method. For the traditional method, we need to compare the calculated z-value with the z-value that's associated with the test statistic. Let's start with that one first. Now here's a question for you. Are we dealing with a one-tailed test or a two-tailed test in this example? Now the fact that the mean doesn't equal a certain number for the alternative hypothesis, we are going to have a two-tailed test. So let's draw a rough sketch of that. My graph is not perfect, but we'll make it work. Now, we have a 95% confidence level. So we need to determine the z-values that correspond to that. On the right, this is alpha over 2, which is half of 0.05, so that's 0.025. And on the left, this is also alpha over 2 with the same area value. Now, to get the z-value that corresponds to a 95% confidence level, we need to use the z-table. And the z-table that I'm going to use is a cumulative area function. So the total area that corresponds to this point is going to be the sum of 0.025 and 0.95. So that cumulative area from the left is 0.975. What we're going to do is find the z-value that corresponds to that total area. And so we're going to get the z-value at that point. So here we have our positive z-score table, and we have a cumulative area to the left of 0.975. So we need to locate that in the table, which is here. So this corresponds to a row with a value of 1.9, and the column is 0.06. So an area value of 0.975 corresponds to a z-score of 1.9 plus 0.06, or 1.96. So that's the z-score that we need to use for this problem. So these z-values are known as critical values. Due to symmetry, the other z-value on the left is going to be negative 1.96. Now, based on the traditional method, we need to compare these critical values with the calculated z-value that we're going to get from our test statistic. But we need to determine if we should use the t-test or the z-test. The fact that we've been talking about z-values is we're going to use the z-test, but you need to know when you should use the t-test. Now, we should use the t-test statistic if we know the sample standard deviation and if the sample size is less than 30. If the sample size is large, if it's 30 or more, a normal distribution will work, and so we could use the z-values. So the formula that we're going to use to get our calculated z-value will be the sample mean minus the mean of the null hypothesis divided by the sample standard deviation over the square root of n. So the sample mean is 169.5, mu naught is 168, which is basically this value, and the sample standard deviation is 3.9. The sample size is 36. So 169.5 minus 168, that's 1.5. And 3.9 divided by the square root of 36 is 0.65. So dividing those two numbers, it gives us a calculated z-value of 2.31. Now, we need to know where that z-value falls in this area. So this region, the region that is not shaded, that is the fail to reject region. The red area that is shaded, this is the rejection region. So notice that our z-value of 2.31 is somewhere in the rejection region. Our calculated z-value is greater than our critical z-value. Thus, this tells us that we need to reject the null hypothesis. So that's the traditional method. So now let's go back to the p-value method. So let me just erase a few things. Now I'm going to redraw the picture first. We still have a two-tailed test. But what I'm going to do now is I'm going to put the calculated z-value on the normal distribution. Now what we need to determine is the area of the shaded region. That total area, the left side and the right side, that's going to correspond to our p-value. And then we're going to compare it with alpha to see if we should reject the null hypothesis or accept it. So everything we've done so far is important to calculate the p-value. So once we have this z-value, we're going to use the same table and get the area. So here is the positive z-score table. Now we have the z-value and we want to find the corresponding area value to the left. So we need to find a row with a value of 2.3 and the column with a value of 0.01 because our z-score, if you recall, is 2.31. Now, the area value that intersects that row and column, as we can see here, is 0.98956. So this is the area value that we want to use, which corresponds to a z-score of 2.31. So that area value is the sum of this area plus this area. So to calculate this area on the right, it's going to be 1 minus 0.98956. So this is 0.01044. And on the left side, this is going to be the same. So in the middle, it's 0.98956 minus minus 0.01044. We don't need that value, but if you want to write it, here it is. This is the area of the region that is not shaded. Now the p-value is the sum of the area highlighted in red on the left side and the right side. So it's 0.01044 times 2. And so that's going to be 0.02088. Now once you have your p-value, you need to compare it to alpha, which is 0.05. So 0.02 is less than 0.05. So we could say that our p-value is less than alpha. So because that's the case, we need to reject the null hypothesis. And so that's how you can do it using the p-value method. So we could say that with a 95% level of confidence, we cannot accept the null hypothesis that the average weight of all residents in town XYZ is 168 pounds. So with 95% confidence, we believe that there is enough evidence to discard the null hypothesis. Now let's work on number 2. A factory manufactures cars with a warranty of 5 years on the engine and transmission. An engineer believes that the engine or transmission will malfunction in less than 5 years. He tests a sample of 40 cars and finds the average time to be 4.8 years with a standard deviation of 0.5. Part A. State the null and alternative hypotheses. So feel free to take a minute and try this problem. So let's start with the null hypothesis. So the factory has a warranty of 5 years. Basically, they believe that the car is not going to have any issues with the engine or transmission for 5 years or more. So we could say that for the null hypothesis, the mean is going to be equal to or greater than 5 years. Now the alternative hypothesis is going to be different. The engineer believes that the engine or transmission will malfunction in less than 5 years. So the mean is going to be under 5. So that's it for part A. That's the null and alternative hypotheses. Now let's move on to part B. At a 2% significance level, is there enough evidence to support the idea that the warranty should be revised? What would you say? Well, let's write down what we know. The sample size is 40. The sample mean is 4.8 years. And the sample standard deviation is 0.5. And the mean for the null hypothesis, let's call it mu naught, that's going to be 5. Now the significance level, alpha, is 2% or 0.02, which means the confidence level must be 0.98 or 98%. Now, are we dealing with a one-tail test or a two-tail test? What would you say? Because the mean can be a range of values for the alternative hypothesis, this is going to be a one-tail test. And because the mean is going to be less than a number, it's a left-tail test. So we're only going to shade the area to the left. Now what we need to do is determine the p-value and compare it to alpha. So in order to find the p-value, we need to find the calculated z-value that corresponds to this point. And then using the z-table, we can get the area under that curve, which will represent the p-value. So let's go ahead and do that. Let's calculate z first. So here's the formula. It's going to be the sample mean minus the mean of the null hypothesis divided by the sample standard deviation over the square root of n. So the sample mean is 4.8, mu naught is 5, s is 0.50, n is 40. 4.8 minus 5 is not -2, but -0.2. 0.5 divided by the square root of 40, that's 0.07906 approximately. So our calculated z-value is about -2.53. So we can put this number here. Now, using the z-table, we need to find the area that corresponds to that particular z-value. So here is the negative z-score table. We want to convert our z-value to the area value to the left under the curve. And we said our z-value is -2.53. So let's go ahead and find the corresponding area value. So we need to look for -2.5, and then we need to find the column that has a value of 0.03. So as we can see here, our value of interest is 0.0057. So that is going to be the area under the curve to the left. So that's going to be our p-value that we're going to compare with alpha. So our p-value, the area of the region shaded in blue, as we said before, is 0.0057. Now, alpha is 0.02. So 0.0057 is less than 0.02. If you compare 0 versus 2, 2 is bigger. So this means that our p-value is less than alpha. And because of that, we can reject the null hypothesis. So we could say that at a 2% significance level, or with 98% confidence, we believe that there is enough evidence to support the idea that the warranty should be revised. And that's basically it for this video. So now you know how to use the p-value method to determine whether or not if you should reject the null hypothesis or if you should fail to reject it. So that's it. Thanks again for watching, and don't forget to subscribe.